In this problem, we have given that a small metal ball is suspended in uniform electric field with the help of an insulating thread. If a high energy X-ray beam falls on the ball will be deflected in the direction of field. Okay, so we have given that this is insulating thread and this is metal ball. So consider this is metal ball and this is suspended in uniform electric field. That means electric field is constant. Okay, and its direction is also given. Now we are going to incidence a high energy X-ray beam on this ball. So if high energy X-ray beam will fall on this ball, then what will happen? This X-ray beam will knock out few electrons from this ball. Okay, so if this X-ray beam will knock out few electrons from this ball, then this metal ball will become positively charged. So will become positively charged. So if metal ball become positively charged, then the direction of electrostatic force on this metal ball will also act in the direction of electric field. So force on the ball, that is the electrostatic force, that will be acting in the direction of electric field, that is QE. Okay, so we can say that force on the positively charged ball positively positively charged metal ball will act in the direction of electric field, will act in the direction of given in the direction of given electric field. Okay, so that's the answer of this problem. Thank you.
Hello everyone. There is a question that two identical metallic spheres of exactly equal masses are taken. One is given a positive charge q coulomb and other are equal negative charge. Their masses after charging are different. ठीक अच्छे तो क्वेश्चन कौन कि लेट अस कंसीडर कि दुटा स्फीयर थिले मेटालिक स्फीयर तो से प्रथम इक्वल मासेस रथिले कि लेट अस कंसीडर कि तांका प्रथम मास थिला कैपिटल एम इक्वल मासेस माने आर भी कैपिटल एम तो याकू प्लस क्यू दिया गला तो सिमिलर चार्ज कहूची आ गोटे के दिया गला किंतु नेगेटिव दिला माइनस क्यू दिया गला ठीक अछि तो प्लस क्यू दिया गला माने सिटी किछि प्रोटॉन दिया हिथिबो तो हम जदी नंबर ऑफ प्रोटॉन केते प्रोटॉन दिया गला ताको बाहर करबा ताले सेटा केते आसीबो जेन होची नंबर ऑफ प्रोटॉन इज इक्वल टू प्लस क्यू divided by charge of proton केते 1.6 into 10 to the power minus 19 तो सिमिलरली आर एन आसीबो केते ना माइनस क्यू डिवाइडेड बाय चार्ज ऑफ इलेक्ट्रॉन केते ना माइनस 1.6 into 10 to the power minus 19 कूलम जोटा कि आसी जीवो सेम क्यू बाय 1.6 into 10 to the power minus 19 तो दी जन का नंबर ऑफ इलेक्ट्रॉन जति की दिया हिची आको नंबर ऑफ प्रोटॉन भी सेति की दिया हिची तो मास केते हबो तो टोटल मास ऐड हेतिबो जति की तो टोटल मास एडेड केते हबो फर्स्ट केस पई तो फर्स्ट केस पई टोटल मास एडेड हबो इक्वल टू एटा नंबर ऑफ प्रोटॉन जति की ऐड हेची इनटू मास ऑफ प्रोटॉन तो सिमिलरली या पई टोटल मास केते आसीबो ना n जति की नंबर ऑफ इलेक्ट्रॉन अछि इनटू मास ऑफ इलेक्ट्रॉन ठीक अछि तो एटा आसीबो n into mass of proton केते 1.6 into 10 to the power minus 27 kg तो एटा किंतु मास ऑफ इलेक्ट्रॉन केते n into 9.1 into 10 to the power minus 31 kg. तो टोटल मास ହେଇଯିବ କେତେ नेट मास आफ्टर एडिंग केते हबो तो प्रथमे थिला m एबे हेई जाईछि केते n into 1.6 into 10 to the power minus 27 एटा ହେଇଯିବ ହେଇ जाईछि केते आर नेट मास एटा ହେଇ जाईछि m plus n into 9.1 into 10 to the power minus 31 ठीक अछि तो आमे कहि परिबो जे आर मास टा अधिक आसी ता माने जो स्टेटमेंट देइथिला कि चार्ज ऐड होई साला परे मास आफ्टर चार्जिंग आर डिफरेंट हां डिफरेंट आसो जो थरे प्रोटॉन दिया है माने जोटा पॉजिटिव चार्ज दिया है ता मास अधिक आसी
A conducting bubble of radius is a thickness T and it has the potential V. Now the bubble transforms into a droplet. Find the potential on the surface of the droplet. Okay. So firstly we write down the solution here and let's make a solution for this question. Okay. So potential at the surface of bubble, potential at the surface of the bubble, okay, bubble, that is V is equals to the K into Q upon small a, okay, and small q is equals to the V A by K. So since bubble collapse collapse into the droplet of radius capital R, okay. So 4 pi into a square into t, that is equals to the 4 upon 3 pi r to the power 3, okay, 4 r to the power 3, and we write down capital R, that is the radius, is equals to the 3 a square into t and whole to the power 1 by 3, okay. Now the potential of the droplet is V dash. So KQ upon capital R is equals to the VA upon 3a square into t and whole power 1 by 3, that is equals to the VA upon 3t and whole power 1 by 3. So answer of this question is V into A by 3t and whole power 1 by 3, okay. So option A is corrected, and thank you for the watching.
Hello everyone, let us start with our question. In this question, what has been given? A non-conducting disk of radius a and uniform positive surface density sigma is placed on the ground with its axis vertical. Now particle of mass small m and positive charge q is dropped from the axis of the disk from a height of capital H with zero initial velocity. So initial velocity is zero, and here it is given that q by m ratio is given as to be 4 epsilon g by sigma. Okay, what we need to find? Find the value of h if the particle just reaches the disk. So what should be the value of the height so that the particle just reaches the disk? Okay, and then we need to sketch the potential energy diagram for this mass, this charge as a function of height, and we need to find its equilibrium position. So that is all we need to do. So how to start with our problem? For example, let's assume that this is a ring. Okay, now it is placed, and we can just define that this may be our vertical direction from which we are dropping it. So this may be our particle which is here, and we need to find what is the velocity at this instant. We need to find the velocity at this instant, sorry, the height at this instant. So what should be the height from which it should be dropped? So basically we need to find what is the value of the h. So from here to here, when it will reach, so this is the potential energy. Okay, potential energy would be lost, and that would be gained in terms of what? That would be gained in terms of electrical energy. Okay, potential energy due to the charge. Okay, so that means we need to apply the conservation of energy. So conservation of energy would say that mgh, it would be mgh equals to the energy due to the potential term. So it would be q into, we can say that, delta v. Okay, now what is this delta v? Delta v basically is here the potential difference between this end and this end. Okay, because due to the potential difference it will try not to come here, and due to potential energy term it will try to reach at this location. So basically that potential energy term would be converted into the this electrical potential energy. Okay, now this is the thing. So how to calculate the change in the potential value? So basically we should know for a disk, so basically it is a disk, this is a disk. So we should know what is the potential for a disk. So at any height, for example, at any height, let's say h, small h, we can assume to be any height. What is the potential written? So v is written in terms of sigma by 2 epsilon. Okay, bracket. Then for example, if a is the radius of the disk, here it is given that radius of disk is a, so a square plus h square. H square, it is the height, square root, then minus h. So this is the formula for a disk. So at any height h, or at any distance h from the axis of the disk, from the axis which is passing through the center, what is the potential given? It is given in terms of this. Okay, now at the capital H, so we can say that at this height, let's say this, assume that this position is 1 and assume that this position is 2. Okay, we can assume this position has to be our second position. Okay, now at this position, what is the value of the height? So height is given as to be capital H, so we can write here as capital H. We can just put the value as capital H. Okay, we can just put the value of capital H here. Okay, now what would be the, this is V1. Now what would be the value of the potential at the center of the disk here? So what is the height here? No height, so H value would be 0. So we can say that sigma by 2 epsilon, and we can put H value equal to 0. So this term would vanish, this term would vanish, then square root of a square, that means a. Okay, so this is the term. So what is the potential difference between the two end? We can say that final minus initial. So we can say that mgh value would be equals to what? Q times, what is final? It is V2. What is initial? It is V1. So we need to take the difference between the two quantities. Okay, now what are the terms which would be coming to be common? So we know that here sigma by 2 epsilon is the common term, so we can take it outside. So sigma q by 2 epsilon, we can take it like this. Then it would be a minus, so we need to minus this term, so a square plus h square in square root, and then when we open the bracket, so it is minus, so here we need to add a minus, so minus minus, that would be positive, so plus h. Okay, now this is the change in the potential value. So how to find the value of h? So h is basically, we can just divide these terms, so it would be sigma q divided by 2 mg into epsilon, then a plus h, we can write it like this. This would be one term minus a square plus h square square root. We can write it like this. Now we can so this is the thing. So there is some simplification which we can do. So sigma by m, we can put the value as 4 epsilon g divided by sigma. Sorry, q by m, we can put the value as like this. So here we can substitute our values. So we can say that h would be equals to sigma by 2g. So we can just write it more clearly. So it is sigma by 2g epsilon and q divided by m. So q by m, the value we can substitute, it was given as to be 4 epsilon g divided by sigma. Okay, g divided by sigma, and then this whole term, so a plus h, then minus a square plus h square. So there would be some term which would get vanish. What are the terms? So epsilon would get cancelled, g would get cancelled, and sigma would get cancelled. So finally what are we left with? So, and 2 ones are 2, 2 2s are 4. So there would be just 4 coefficient, sorry, 2 coefficient. So h could be written as 2 times. We can just multiply, there would be 2 left, so we can multiply 2 here. So it would be a plus h minus 2 times square root of a square plus h square. It is like this. Okay. Now what we can do, we can take this a plus square root term to be on this side. So it would be 2 times a square plus h square in the square root. Okay. Then here would be, it is 2a. Then here would be 2h and then minus h. So it would be plus h, only plus h. Okay. Now how to find the value of h? Ultimately we need to find what is the value of h. So we need to square this term. So if we square this, so it would be 4 and then it would be a square plus h square. So here if you were to expand, so 2a plus h whole square, so it would be 4a square plus h square plus 2 into 2, 4ah. So it would be 4ah. So what are the term which would cancel? So the term are 4a square would get cancelled from here. So we are just left with 4h square. And then we need to bring h square here. So ultimately it would be 3h square equals to 4a into h. Okay. Now there will be two roots of this. So one would be, if we could write it like this, so it would be 3h square minus 4ah would be equals to 0. If you can take h to be common, so it would be 3h minus 4a equal to 0. So h would either be 0 or h would either be, it would be 4a divided by 3. So either h would be this or this. So h equal to 0 is not a solution because we need to drop it actually from some height. So our answer for the first part would be that h should be equals to this. So this is the answer for our first part. Okay. Now what we need to do, we need to sketch the potential energy of the particle as a function of its height. We need to sketch the potential energy. So basically we need to write the potential energy at some location small h. Okay. What would be the potential energy? So potential energy would be basically two potential energy. One will be due to charge. Okay. And then other would be due to its mass. So that would be potential energy mgh terms. So one would be due to the electric potential and another one would be due to the height. So what is the potential energy due to height? We can just write it, for example, at this location. What would be the potential energy? mgh. And what would be the potential energy due to charge? What would be the potential energy at any height? We can write it in terms of this. So potential multiplied by the q charge. Okay. So basically if you were to write potential at any height, we can just write for the second part, potential at any height h would be equals to what? Due to charge. So how to write the potential due to charge, energy due to charge? So we multiply charge with the potential plus mg into h. Okay. Now what is the potential given? How is the potential given? We have just seen for the disk at any height h, potential is given as sigma by 2 epsilon a square plus h square square root minus h. So we can just put the value. So it would be q, we have put the value, then it would be sigma by 2 epsilon. Okay. This term, then we need to put a square plus h square square root and then minus of h. Okay. Plus mgh. Now this is the value. Okay. Now ultimately what we can do, we can if you want to take common, we can take common, but what we can do, we can put the value of q. What is the value of q? So basically we know that q by m ratio, we know that q by m ratio is what? If you could see, q by m ratio is given as to be 4 epsilon g by sigma. So what would be the value of q? So it would be 4 m epsilon g divided by sigma. So this would be the value if we could multiply here. So we can put the value of q. So we can put the value of q and then at this location. So if you put the value, so it would be q value would be m. Just we could see what is this, 4 m epsilon g by sigma, 4 m epsilon g by sigma, and then sigma by 2 epsilon, and then a square plus h square square root minus of h plus mgh. Okay. So what is the term which are the remaining portion? Let us rewrite this portion, u of h. So u of h, basically now it is just a manipulation how to we do it. So it would be so this epsilon would get cancelled, sigma would get cancelled, and it would be just 2 mg. It would be 2 mg and then bracket term. So a square plus h square square root in terms of square root minus h. Okay. Plus mgh. Okay. Now what we can do, we can do a further replacement. What we can do, so we can take mg common first of all. Okay. Mg would be common. Now what we can do, we can just multiply 2 with this part. So it would be a square plus h square square root 2 times. Then 2 would be multiplied by this. So minus 2 and then minus 2h, and here it is h, so we can say that it would be minus h if you were to take this into account, addition into account. So this is the potential energy at any location. So if you were to find the equilibrium position, so how to find the equilibrium position? So for finding equilibrium position, okay, what would be this? So it would be for finding, so it would be du by dh would be equal to 0. Okay, we need to find the equilibrium position. Let's check. We need to find the equilibrium position. So du by dx would be equals to 0 because force is 0 at this location. So force is represented at du by dh. Okay, so we can say that we can just differentiate this equation. We need to differentiate this term. So u would be equals to, if we were to differentiate du by dh, we can take mg to be common. Mg is common. Then it would be 2 divided by, we need to square, take the division of the square root term. So it would be 2 a square plus h square, and we need to differentiate in terms of h. So it would be into 2 into h, then minus 1, and then it equals to 0. We can write it like this. Okay, then what we can do? So we can take this 2 to be cancelled. Then it would be just 2 h upon a square plus h square, square root, then minus 1. So minus 1 we can take other side, so it would be 1. And after that, what we need to do, we again need to square these two expressions. So it would be 4h equals to a square plus h square. Then it would be 3. So it is h square basically, because we are squaring this. So 3h square equals to a square. That means h equals to a divided by root 3. So this is the value of the equilibrium position. So at this height, a by root 3, so it would be in the equilibrium position. Now basically what we need to do, we need to plot. So even though we know the equilibrium position, so that means we know where the slope is getting to be 0. Okay, where the slope is getting to be 0. We know this position. Now we can plot it. How to plot it? So basically, if we are choosing our axis, let's assume that this is this may be our axis. Okay, let's say this is our one axis, and let's say this is our another axis, h axis. Okay, we can say that this is our h axis and this is our u axis. Okay, u as a function of h. So what is the value of u? For example, u value is given as to be mg to a square plus h square minus h. We can write the value of u. We can just represent the function here as uh would be equals to, what was the value? It was equals to mg bracket 2 a square plus h square, square root, then minus of h. It was something like this. So at h equals to 0, for example, here at this location, h equals to 0. So what is the value? Mg, then 2, then h is 0. Basically this term is vanished, this term is vanished, equals to just 2 mag. Okay, this is the value. Okay, now this would be the maximum value. This would be the maximum value of u. Why? Because we know that this function is in terms of decreasing. So we can get the maximum value here as at x equals to 0. So basically not at the maximum value, but basically at u equal to 0, sorry, h equals to 0, we get the value of u as 2 amg. So it is a positive value. Maybe here there would be 0, it is 0, so it would be 2 mag. Okay, this is the value. Now there is a equilibrium position. At the equilibrium position, h value is given as to be a by root 3. So we can put the value of h here, and we can get what is the potential energy at the equilibrium position. So we can get the potential energy at the equilibrium position. How would be the potential energy at h equals to a by root 3? We can again substitute all these values in our potential term. Here the value of h as a by root 3. So what is the answer which we would be getting? So it would be mg, then twice square root. So a square plus h value. H value is, if you could see here, it is h square. So we can say that a square by 3. So it would be a square by 3 minus a by root 3. So if you were to solve this part, so the value would come out to be, this value would turn out to be root 3 mag. Okay, this is the value which is coming. So this where would this value exist? For example, this is the value, and this is, let's assume this at this height, a divided by root 3. So what is the value, whether it is greater than 2 amg or it is less than? So it is coming out to be root 3. So root 3 is less than 2. So that means our value would be at point would be something like here. So here the value would be root 3 mag. So that means our graph is turning to be like this. Okay, now when we are varying h to be infinity, if you put h to be infinity, so our function would approach to be infinity. So that means it will go here, come down, and then it would move. So we can basically make it another way. So it would be, first of all, it would be something like this. It would be like this, touching the equilibrium position, and then it would be moving like this. So this is the graph. So hope you have understood this explanation. Thank you.